Cassandra in some cases. Document data stores. Well, 10 years ago, the first object data stores started to arrive, but it's only like 4 or 5 years ago when MongoDB and CouchDB started to implement the really useful document data stores, where you just store one JSON object without a schema, and you can change the schema in between, while the data store can still access the JSON data and index that. Graph data stores, also something relatively new, as we nowadays use the graph data store mostly for either network storage, so social network storage, or recommendations storage. Depends on the way you want to calculate your recommendations in this case. If you take this data stores overview to the examples, where you can see that relational data stores used to be MySQL, Postgres, Oracle. Well, those are products that started their life already decades ago. While the key value stores like Redis and Riak are really brand new products, they only have been around for maybe 3-4 years. Columnar data stores, Cassandra already mentioned that one. Another very popular one is HBase and InfiniDB. Document stores, MongoDB, Couchbase, and GraphDB's Neo4j and Titan are really popular data stores. But these data stores, you can obviously use them in the cloud as well. If you get a computation node and you install MySQL on it, that would work. Same goes for Redis or Riak or any other of these data stores. The question only is whether you have a performant instance in your cloud provider that is capable of handling the IOPS, for instance. And of course, these cloud providers also offer those type of data stores as a native data store. So AWS has RDS and Aurora as their relational data store, while Google has Cloud SQL. Key value stores, DynamoDB and Datastore are really suitable products for this, and they're really fast. And obviously, you will pay as you go. So instead of paying for an instance entirely, you only pay for the amount of keys and values you're storing in the system. Columnar data stores, Redshift and BigQuery are popular within large companies because you only have to pay as you go as well. Document data stores, SimpleDB and Bigtable are equivalents to MongoDB and Couchbase. They work similar. They have similar interfaces. And only AWS has a capability of using a graph database on top of DynamoDB, while Google doesn't have one. But as you can see, also the cloud providers are providing a polyglot already. And even a system like Hadoop becomes a polyglot nowadays. The first version of Hadoop using HDFS had the MapReduce paradigm to query your data from Hadoop. And MapReduce is basically programmatically retrieving data from HDFS. You could abstract that later with the new Pig and Hive options. And especially Hive was really popular among people who are in BI, because now you can run SQL on top of HDFS. The new Hadoop is all around a polyglot. So they have the new improved HDFS storage, but they're now using Yarn, the resource manager, in between. And the resource manager allows other plugins to run in there as well. So you don't have to write MapReduce jobs anymore to retrieve the data. It's now an abstraction layer, which allows you to now do still MapReduce jobs, use the same old Pig and Hive to do querying, but it also allowed other plugins like the graph database to be integrated, or columnar data stores to be integrated on top of HBase. And most importantly, Presto by Facebook is now using Yarn as well. And that's becoming a really popular BI platform at the moment because it's really cost saving compared to using other solutions like Greenplum or Vertica. So Hadoop itself is becoming its own polyglot ecosystem. So now we get to the polyglot persistence. You can use various storage systems for different problems. As the complexity of our websites or of our enterprise applications started to increase, we need to store things in a different way. We need to solve things in a different way. And that's also what polyglot persistence is all about using the right tool for the right job. So, for example, you could use Postgres for financial data because it's really, really safe and it's crash safe. While MySQL is really good for handling, it's basically a trade-off between the two, between the really persistent storage and ensuring crash safe recovery. And with MySQL, it's really suitable for serving out exactly the same data, but then a little bit faster and allowing you to do a small trade-off in the consistency. MongoDB is really good at storing profile data. So you just have one big JSON blob, you push that to MongoDB, and then MongoDB can index certain fields in there. And you can use that as a secondary index in your queries. You can use Cassandra for real-time streams. And why can you use it? You just push the data into Cassandra, and Cassandra will allow you to do a columnar retrieval of this very same data. So you can push in, for instance, log files, and they are all delimited, and then you just query everything in the third or fourth column that is, for instance, matching a certain criteria. And of course, you can use Redis for recommendation storage. It's a really fast in-memory storage system that isn't using a lot of overhead of your servers. However, if you, in the end, use all the memory that is assigned to Redis, it will no longer store anything. It's not a persistent storage. If we take that to the same example that we had with microservices and the polyglot programming, polyglot persistence now shows you in this graph that for the login service, we're using MySQL, for instance, for profile details, MongoDB, for the billing service, Postgres, and in the example of the recommendations, we're using, in this case, Hadoop for storage of, for instance, log events, and then processing that log event into some output that we use Redis for to send it to the end user. So in this sense, we are already using 5 different data stores. So this company has quickly become a polyglot persistence. To illustrate this a bit more, how does it come that we get into this polyglot nowadays? I want to give you a small example project of a small company that is still using one single data store and is completely MySQL minded. So if you look at the project management lifecycle, we have an initiating phase where someone has a brilliant idea and wants to implement that. And then we get to the planning phase where we plan our new product. We get to the execution phase. A lot of people start working, start typing code, testing that, and then in the closing phase, everything gets closed. On the development cycle, we see that during the planning phase, there's the requirements analysis. There's the design phase. Someone makes a couple of mock-ups, maybe a schema, for instance. In the execution phase, the development is started and the application is developed, it's being tested, it's being implemented. And this is also a lot of times a circular development process. And once the application has been finalized, we get the handover to the operations side of the company. And then in the end, of course, there's a systems decommission. I've grayed this out because nowadays that doesn't happen a lot anymore. Because most of the time, once it is in production, you need to rework on your project using a continuous delivery. So this is more the new type of work. So you never decommission your system, you only replace smaller parts of your system. And that's also why people are using microservices a lot, because with a microservice you can replace another piece of your application quite easily by only changing a small bit into a microservice or replacing a microservice with another microservice. So you can again go through the circular development. So if you look at that development process, we require to get a recommendation system done. For our recommendation system, the storage must be really fast. And the document that we deliver to the end user must contain user details. Otherwise, the front end cannot handle anything user related. And the data must be kept until the next time the user visits the website. Now, if we then choose the right tool for the right job, we would use a document data store. Because we need to send a document to the end user, we cannot use something like Redis where we just store some piece of information and back to the user, because it's not persistent storage. So we need to have something that persists. So this company decides to use MongoDB because MongoDB is suitable for this case. So development is being started. But what happens after that development phase? Well, the operations has to set up the application, so you get into the deployment of the application into the infrastructure of the company. Monitoring is added to see whether the application works. Most probably smaller checks through load balancers. Is it giving 200s or 501s or 404s? What should we do in that case? And if everything is fine, the product is being handed over to the operations side of the company. And this is basically the end of the development cycle. But does it end here? Well, it doesn't end here, because we need systems monitoring. We need to create backups. We need to scale our application if necessary. We need to do software updates. And I'm not speaking about software updates in a term of new application updates, but more or less like, what software is it using? Program language, storage. Also, the integration with BI is most of the time forgotten. So after development cycle, some application is being delivered, and then BI is interested in the data that it creates. So that always has to be done afterwards. So from the ops perspective, it's totally different. It's not like you have a long initiating phase and a planning phase and execution phase and some small closing phase. It's the other way around. You have a small initiating phase where they didn't know anything about this application. In the planning phase, they do most of the time get a bit of involvement, like, hey, we want to implement something like this. Is it possible that you start to host this new piece of software and this new storage system? I grade it out because that doesn't always happen. Then you get into the execution phase where the development actually started, and then the closing phase is a really big one for the ops side. You get a handover to ops, and then you get a really long maintenance. You have to keep the systems healthy. You have to monitor those systems. You have to scale them. And then in the end, maybe a system's decommission. So this is a whole different picture. If I zoom in on the systems monitoring, for instance, so far this company has supported MySQL